Hey everyone, hope you're enjoying our previous classes. So today we are going to learn about data processing method in NLP like tokenization and stop word removal. So stay connected and enjoy the session.
So let's start the discussion from tokenization. So going to the tokenization, first we need to understand what is a token. Tokens typically corresponds to words, numbers, or any punctuation mark. But the exact definition can vary depending on the specific requirements of application and the complexity of the language. Now, each language has their own structure. Now, in English, when we put a dot, we understand the sentence stops there. In Odia, when we put a bar, we understand the sentence ends there, right? Likewise, every language has their own way of stopping or own way of words and meaning. A token, when we create, it's a small correspondence to a word, number, punctuation mark, or any white space, we call a token. Now, it may happen it is a word, but it may not be a word. So the complexity of this token or the small form of token or small form of that whole sentence, we call it a token. Now, if we say commonly, most commonly we call it is a word or individual words separated in spaces or individual words separated in different segments. So we can say a word divided into sub-words. Like if I say every day, so every is one part, day is another part. So those are, we call the subwords. So token is a very small unit in a sentence, we can say, but it may be a word or not a word because it says subunits of word, you can say, or it can be a morphological token like in space, comma, or any number, okay, or character level token like somebody say don't, they put a comma in between uh, N and T, it can possible. So what is a punctuation? Punctuation mark can be treated as separate token if they convey meaningful separation, like comma, any syntaxes, full stop, semicolon, any brackets. All these punctuation also can be a token. Any number is also can be a token. Like if somebody say my age is 15, or if somebody is saying they're uh, they're answering in a point manner, like here 1, 2, 3. So anything can be token. Now finally, the morphemes. Morphemes in some advanced tokenization method, token may consist of a smaller linguistic unit like stems, prefix, suffix. Like I will say a blue sky. So blue is a color and it is a prefix for this sky. Suffix. There are suffix with the example as like uh, weekly once. So weekly is also a word definite different word. Once is another. Now weekly, that means weekly means each time in a week, right? So the stem, the root word is week and we'll apply ly. So now those stuff are divided and from there we can get the token. So if we say why we do this tokenization process, okay? So if we are dividing, why not we dividing into words or why not we dividing into a rule as per the language? Why we are dividing in a token? Now, token is based on the model of the NLP, and we divide into token to manage, analyze, and interpret the text. Okay. So mostly we do the text analysis by dividing the whole sentence into token. Now, each word can be used for various analytical purposes, and that's how we divide that. Now, in tokenization, we have different methods like part of speech tagging. So each token can be labeled with a respective part of speech, like noun, verb, objective, etc. So that will be helpful to synthesizing and analyzing the whole sentence. Okay, we'll understand the details what is tagging, speech tagging. Similarly, it also helpful tokenization to name recognition. Okay, so like in a particular sentence, there may be a name, and that name we have to understand it's a name, not a noun verb or adjective or any stop symbol. So that also useful to understand. Then machine translation. Once we get the token, we can apply those tokens into our algorithm, because any model has back of that we have algorithms. So those algorithms will be useful for token. Sentiment analysis, the identification and analysis of token help determine the sentiment expressed in text. Sentiment analysis means emotion. If somebody is writing, due to your services, I am feeling very sorry. I was frustrated because of your uh, uh, services. So we can understand that person is frustrated and very sad. So we understand the sentiment from their text and we'll reply in a very like empathetic manner. Okay, so we can reply, yes, we understand we have issues based on our services. We may face issues. So that's how the auto replies will work. So we can do the sentiment analysis. Now let's take one example how the tokenization process happening in the system. Now here you can see there is a text, hello world, how are you doing today? Now this can be divided with hello, comma, world, now explanatory symbol, then new sentence starts with how, then comma, are you doing, comma, today, and finally question mark. That means the whole sentence given is small uh, tokens. Now here you can see there are commas, there are explanatory symbols and question marks. So the words are there. The other uh, punctuations are also there. So separate words, most tokens will first split the text on white space, which initially separate the hello world, how are you doing, and today. Now again, the world is again divided into two parts, world and explanatory symbol. Okay. Now, when we handle these punctuations, okay, we understand there is another word which has meaning. So we detach that word and apply the correct tokenization process. So like here, hello, when we do hello, we put a comma. So we separate that comma and hello. Okay. Similarly, when we put word and explanatory symbol, again we divided word and the explanatory mark to understand better. And once everything is done, we push it to the to the model to process that words, because there are some words which don't have meaning, like if are a verb, okay, and when are would be there, we can understand there may be question or a answer or a information or a sentence. So finally, we get a question mark indication, which we understand it's a question. Okay, so now it is passed to the algorithm. So when we do the tokenization, exactly what are the processes we do? We do white space tokenization. Okay. So most of the time the words are separated with space. In some language, it may not separate it. It all are clubbed together. But most of the language, the words are separated in space. Dictionary-based tokenization. Now, if there is a meaningful word, we divide it into small chunks. Then we do the rule-based tokenization, like world. There is the explanatory symbol, and we know one is word, other one is a punctuation. Then pen tree tokenization process is there. So whatever we want to remove, we will remove them. And then spacey tokenization, if there are extra spaces in the sentence, we remove that. Most tokenization. Okay, and finally, we go for the sub-word tokenization, where we divided the word into small pieces or chunks to understand it better. Now, if somebody will ask, tokenization is nothing, it is basically making of the word. The answer is no. If we go to the word, what is the definition of word and token? Both are different. The word of definition of a word, we can say a word, on the other hand, is a specific type of token that generally represent a complete and discrete unit of meaning within a language. Words are composed of one or more characters and are typically separated by space in language like English. However, identifying word can be more complex in languages that do not use space, such as Chinese or Thai languages. Whereas token is very different. A token is the smallest unit of text that is treated as a single entity in the context of tokenization. Now, both are small, but word each have specific and discrete unit, where a token don't or may not have the meaning. Okay, but it has some meaning to the model. So in word where we are using mostly text, in tokens we have words, numbers, symbols, punctuation, and even part of words depending on the granularity of the tokenization process. Like as I mentioned in our everyday example, every and day both are separated or subwords. The definition of a token is determined by the rules used in the tokenization method. Okay. So now you can say, why is there any universal rule? The answer is no. It is based on the algorithm which you choose to process the language. And based on your algorithm, the tokenization process has to process. Now, most of the time we understand, we are saying that it is based on the model, but most of the LLM means large language model, they use the common type of tokenization. They are making it standardized. So everybody will be used it as a standard method. Now, if I'm saying that standardization, again, based on different languages, the tokenization process changes. Yeah. Even if you go to the website of GPT, it explained in a detail, like what is the tokenization process. And from there also you can study what exactly is tokenization. If you go to the either documentation, product documentation, or in common also, you can go below and you can find more details application of industry. Here you can see there is a example of feedback summary, how it is divided into tokenization process. Now here you can see that they are explaining some examples of what are the processes available, okay, and how they are useful. So you all did the summarization, right? Here you can get direct simple text summarization, documents and codes as well. And you can use that to do the text summarization if you want. But anyway, so it has somewhere I'm not able to see right now. There are tokenization processes and it explains in detail what is tokenization process. Okay. And this is, okay, it will be helpful for during your, if you go for what we call it, project, that during time, some of the information will be very helpful for you because it uses the all these techniques and shows the examples here. So you can use those techniques in your coding to reproduce the task what I am giving to you. So anyway, so all these language models, they use tokenization process to divide the any instruction into small tokens. And from there, they can analyze what exactly is the meaning of the sentence. Now, strictly refers to a full lexical unit that carries meaning in a language. And token means can be words, part of words like a suffix or a prefix, punctuation mark, symbols, white spaces, everything is part of token. Used primarily for semantic and like any syntactic analysis as it carries meaning, the words. Okay, whereas token serves as the operational unit for further process of NLP tasks like parsing, syntax analysis, and machine learning. Okay, so if we understand what is the use of tokenization, mostly it is used in NLP, natural language processes. So mostly when we are giving any text, then only the tokenization process come into picture. Then it will pass that to the system to understand. Okay, and once the system understand, then it will respond. So mostly it is used in LLMs, large language models. And the board use of, like here it's already mentioned, the board use of token age NLP allows for the versatile application across the different languages and text format. Tokenization must adapt to handle various text elements uniquely, like separating punctuation from words. Okay. Whereas word understanding and analyzing word is a crucial task related to any language model. Now, this is not a new concept. Tokenization process is there in research for almost more than 50, 60 years. So it is there before the AI also, because when there is a language translation happen, first we do the same thing, we do the tokenization, but now we are doing this at the digital level. So that's how the name tokenization is very popular. But you understand if somebody is know two languages, let's you know two languages, English and Hindi. So when you read the Hindi, in your brain, you divide these words, then you translate into English and write into the book or your note. So what exactly you are doing? We are putting the same technique into a machine and we understand the words. We divide into tokens, we pass that into model to process them, and then we execute what exactly is the instruction. So that's how the tokenization is very popular in large language models. And it also gives a more flexibility and instant tokenization is mostly based on the algorithms which is behind the scene. And generally whereas word is more stable and some tokenization process also use the linguistic technique to tokenize. So this is the NLP, but why we do tokenization? What what is the requirement of tokenization? As I mentioned, it is understand. But why exactly in LLM? Why we do? So if I will say, what is the color of sky? So when I'm saying that what is the color of sky, most of you know the answer may be blue. Some will say it may be dark. Some might say, okay, it is orange. So the color of the sky may be blue, orange, or dark, but depending on some conditions. Okay. So what LLM do? LLM integrated all its library, okay, and try to find the sentences very similar to the sentence what I did. What is the color of sky? And he tried to find out what should be the answer, right? Now, natural language processing or LLM models are purely mathematics. They have statistics and they create a whole graph or you can say chart and out of that it will find out what is the percentage of the uh, answer blue or orange or dark. Okay. And if it will find the maximum number is like, let's consider 52% probability to be blue, it will answer blue. Okay. Now, I'll put the question in more detail. What is the color of the sky in night? Right. So I put a specific word as midnight. Now, again, it will do its algorithm and find out what is the maximum probability of the answer. It will find definitely it is dark. It will reply dark. Okay. If I make it more specific in the last time of night and in beginning of the morning. Okay, now it's a very more accurate and it will give a timing, or in the instead of in the night, I'll say in the morning, 5 a.m. more accurate. So you may say, oh, it may be a different color, it may be orange in nature. So it can reply that. So now how it is happening? It is based on its all the language models, all the data information, whatever trillions of the data it has, it is doing the statistic probability. And from there, it is extracting what should be the probability, best probable answer for your question. Let's take another example. Okay. I try to learn something new every day. Now in GPT-3, there is a area called playground. Okay. If you go, you will see. So now if you go to the playground and you put the sentence, I try to learn something new every day, and put your cursor there. Okay. Automatically it will say what is the percentage of each of these subwords. So the token, which is every, is having 49.67%. Slash same is 20.66%. Every day is 17.03%. That means your 49% I can divide it into segments. Okay. Each about all those is divided. Now, once it is divided into tokens, the based on our understanding in prompt engineer, it has to give that meaning to the system. So we did the prompt. I tried to learn something new. Completion. Okay. Now here, the prompt captured and it passes to the system or language model to do the analysis. So the system divide it into separate segment, every, other, each, every day, and check what are their occurrence across all the language models exist for this LLM. Okay. And it found, okay, 49% is for every. Okay. Now it understands the completion is every day. I try to learn something new. What is the space? Space mark should be completed with every day. Okay. Now, instead of every day, I can put every hour. It may possible. But what is the most probable answer? Day is most probable question. Or if I say instead of every, I can put each day. It is not so much probable. I can say each hour, each time. But if there is a day, every should be there. And the probability of every is 49%. If I'll say, what is the percentage of every day instead of I'm dividing into every and day. So it is saying that, okay, 17% chances is that it may be every day. Now, yes, it may be every and day. That's a separate thing. But 17% chances is that it will be every day, right? I try to learn something new every day. So if you combine every is almost there, every day is there. So mostly it is every day. Some saying that I try to learn something new, no, nothing, it will be blank, but new itself, it's a uh, new line, like it will be say something, space, then new line should be start. But can we consider it as a new? Some percentage it is saying that here it can be a 21% of new as well. Okay. But what is the highest percentage here? Every. Then next is every day. So everything which is very highest percentage will, the prompt will take that as the probability answer. Okay, if you will disconnect, you reconnect on the same link, because I can see we will disconnect in next 30 seconds. So now in this sentence, okay, if we pass that for the tokenization, It will divide it into small chunks like quick, brown, fox, jumps, over, lazy dog. Now, THED don't have much meaning here. Or if I say the quick brown, instead of the quick brown, I can say the quick brown. After that, brown is there and quick is there. Again, it is, we can understand what that is speed.
So hope you enjoyed our today's session. If you like this video, then do like, share and subscribe our channel.